In this question, we're told the total cost of ordering some t-shirts is made up of a set fee of $115 and a cost of $3 per t-shirt. We're also told that the company requires a minimum order of 25 t-shirts and the school can spend a maximum of $800. And we're asked to determine all the possible values of the total cost C and the number of t-shirts N for this situation. Well, let's see what we can pull out of the information given here. For example, we know that C is equal to the total cost, and we know that N is equal to the number of t-shirts. We're also told that the setup fee is $115, so that represents the initial value. So $115 is equal to our initial value. And the $3 per t-shirt, the giveaway here is the term per, means that $3 is our rate. So what we might want to do is use this information to come up with an equation that represents the situation. Well, if we think about it, our total cost C is going to equal our initial value, $115, plus the cost per t-shirt. So this would be $3 times the number of t-shirts ordered. Another way to say this is that the dependent variable is equal to the initial value plus rate times the independent variable. So now we have to incorporate the information about the minimum and maximum values. Well, let's draw a little table of values here. And what we'll do is we'll put the dependent variable here and the independent variable here. And we'll stick minimum value here and the maximum value here. So a minimum order of 25 t-shirts means that N minimum would be 25. And a maximum expenditure of $800 would mean that the maximum value for C here would be 800. And what we want to do is figure out what are these other values here for min and max. So this becomes an ordered pair table, and so if we want to start to try to find C, we can just simply plug 25 into the equation and see what we get. So in this case, C would equal 115 plus 3 times 25. This would equal 115 plus 75. We add those two together to get 190. So this means if we ordered the minimum number of t-shirts here, then the minimum cost would be $190. Now let's look at the maximum side of things. In this case, we'd plug 800 in for the total cost and solve for N. So we would get 800 equals 115 plus 3N. Subtract 115 from both sides, so 800 minus 115 equals 115 minus 115 plus 3N. The 115s cancel out. 800 minus 115 is 685 equals 3N. Divide both sides by 3, and so N would equal 228.333 repeating, or if you like, 228 1/3. So now we can replace this value here with 228 1/3. But then you have to ask yourself, can you make 228 1/3 of a t-shirt? Obviously you can't. You don't want a third of a t-shirt. So what you have to do is round this value down, otherwise you'll go over the total cost. So really our maximum value would be 228 t-shirts. So let's add another row here to represent our true maximum, which would be 228. And let's go back here and figure out what would that total cost be. So just like before, we take 228, plug it in for n, and see what our total costs would become. So we'd get C equals 115 plus 3 times 228. So C equals 115 plus 684. And if we add those two numbers, we get C equal to 799. So that becomes our true maximum, or our realistic maximum here. So now we know all the possible values for n and all the possible values for C. So the possible values for n would be our minimum, 25, and then everything up to and including 228 t-shirts. And our possible values for C would be 190 at the minimum, all the way up to $799 for the maximum. Now we need to qualify this a bit. For the possible values of n, 25 to 228, that is in increments of 1 t-shirt. Whereas for the possible values of C, the dollars, this is in increments of $3. So another way to look at this is we could say this would be 25, 26, 27, all the way up to 228 for the number of t-shirts. And for the total cost, it would be 190, 193, 196, all the way up to $799. And there you go.